Predicting restaurant tips using descriptive and predictive analytics in Excel. Let's talk about the problem statement. Restaurants often rely on gut feeling to forecast tips. But what if we could predict tip amounts with data? Could variables like total bill, group size, time of day, gender, or smoking habits influence tipping behavior? In this project, I set out to explore what factors actually impact tipping. Can we build a predictive model using just Excel? Which variables are statistically significant predictors? Tasks performed. 1. Data cleaning and preparation. Loaded the dataset and checked for missing or inconsistent values. Converted categorical variables to numeric using if formulas. 2. Descriptive analysis and visualization. Used pivot tables and charts to explore average tips across categories. Formatted all y-axis starting at 0 for accurate visual comparison. Converted sum to mean for fair category comparisons. 3. Initial observations. Noted slight differences in average tips across gender, smoking status, day, and time. However, unsure if these variations are statistically significant or due to randomness. 4. Regression modeling. Built 2 multilinear regression models using Excel's data analysis ToolPak. Model 1. All independent variables included. Model 2. Only size and total bill, as initial analysis suggested these had stronger relationships. 5. Evaluation metrics. Predicted tips using regression equations. Calculated error is equal to actual, predicted tip. Measured accuracy using root mean square error. First create insights from pivot charts. Gender-wise tipping. Male average tip, 3.09. Female average tip, 2.83. Observation. Slight difference, but possibly due to chance. Gender may not be a strong predictor of tipping. Smoker-wise tipping. Smokers average, 3.01. Non-smokers average, 2.99. Observation. Minimal difference. Unclear if statistically meaningful. Smoker status appears weak as a predictor. Day-wise tipping. Sunday saw the highest average tip, while Friday saw the lowest. Observation. Some variance, but likely due to random factors. Day doesn't show strong predictive power. Time-wise tipping. Dinner, 3.10 average tip. Lunch, 2.73. Observation. Dinner tips are higher, but it's unclear if this is significant. Time may not be a reliable predictor. Let's create a scatter plot chart. Take data from the main dataset. Go to Insert, Chart, Scatter Plot. A scatter plot of total bill versus tip shows a clear positive correlation, indicating that as the total bill increases, the tip amount also tends to increase. This visual reinforces that total bill is a strong predictor of tips and plays a key role in the regression model. Let's create another scatter plot chart. Take size and tip columns from the main dataset. Go to Insert, Chart, Scatter Plot. A scatter plot of size versus tip shows a positive trend, meaning that as the group size increases, the tip amount tends to rise as well. This indicates that group size could also be a useful predictor in the regression model, though the effect is more moderate compared to total bill. Now let's convert character values to numeric for regression analysis. Use if conditions or label encoding in Excel to assign numbers. For example, sex, female is equal to 0, male is equal to 1. Smoker, no is equal to 0, yes is equal to 1. Day is equal to 1. Time, lunch is equal to 0, dinner is equal to 1. This step is important because regression models require numeric inputs. Converting categorical data ensures they can be included in the model correctly. Let's create first regression model. Regression statistics. Multiple are 0.6856. There's a strong relationship between the inputs like total bill, size, sex, etc. and the output tip. R square 0.4701. The model explains 47% of the variation in tip amount. That's pretty good. Adjusted R superscript to 0.4520 adjusted for number of variables, slightly lower, still decent. Standard error 1.02 on average. Predictions are off by 1.02. Observations 244 model was built using 244 customers. About ANOVA. F is equal to 26.06. This checks if your model is better than random guessing, and it is. Significance F equal 1.19e28 super small, equal your model is definitely meaningful. Coefficient stable. Intercept 0.8460.098 starting tip, when all variables equal 0. Not very useful on its own. Gender 0.0320.81 gender does not affect tip. Smoker. Yes 0.0860.56 being a smoker doesn't matter much for tipping. Thursday 0.137 0.77 tips on Thursday are not different from others. Friday 0.025 0.94 Friday has no unique effect. Saturday 0.096 0.56 Saturday doesn't change the tip either. Dinner 0.061 0.87 dinner time doesn't matter for tips. Size 0.176 0.050 bigger groups tend to give slightly higher tips. Total bill 0.0942.34 19 most important factor. Higher total bill equal higher tip. Strong and statistically significant. Conclusion. Tips increase mostly due to total bill, size, no strong impact from gender, smoker, day of week, time lunch dinner. Model 2. Only total bill and size. Regression statistics. Multiple are 0.6835 still a strong relationship, even with just two inputs. R square 0.4671 This simpler model explains 46.7% of tip changes, very close to model 1. Adjusted R superscript to 0.4631 better adjusted score. Fewer variables is equal to less overfitting. Standard error 1.01, even slightly more accurate than model 1. Observations 244 same dataset, still 244 records. ANOVA. F is equal to 105.3 very strong F statistic. Model performs significantly better than random. Significance F is equal to 2.52 33 tiny value means model is statistically very reliable. Coefficient stable. Intercept 0.6690 0.003 base tip amount. Size 0.1920 0.047 bigger group higher tip. Statistically meaningful. Total bill 0.0935.44 20 extremely important. Higher bill higher tip. Model 2 conclusion. With just two variables, you still predict tips almost as well as model 1. Eliminate noise from weak predictors. Get a simpler, cleaner model with similar accuracy. Now we calculate prediction tips, error, RMSE. Key takeaways. Total bill and group size are strong indicators of tip amounts. Variables like gender, smoking status, time, and day do not show strong correlation with tip amount based on p-values and mean comparisons. Further analysis is required to confirm if those weak predictors could contribute to a nonlinear model or interaction effects. Conclusion. This project demonstrates how we can use Excel not just for basic analysis, but also to build predictive models using multilinear regression. While several variables appear to influence tips visually, statistical testing revealed that only size and total will have meaningful predictive power. Thank you.